Hello students, I Rohit Shah, Assistant Professor in Shamlal College, is back with the fourth lecture in Mathematics of Finance. The concept that we would be considering today is present value. Present value is nothing but the principal. So when we talk about present value of one single amount which is due after n years, we are talking about principal. So, if interest is compounded continuously, that is my m is equals to infinity, in that case we all know that amount is equals to p e to the power rt, where p is nothing but the present value. So we can rewrite this formula as p is equals to amount divided by e to the power rt, which is equals to amount multiplied by e to the power minus rt. Therefore, present value if interest is compounded continuously is amount multiplied by e to the power minus rt. But if interest is compounded m times in a year, then we all know that the formula for amount is equals to p 1 plus I to the power n, where p is nothing but the present value. So we can rewrite this formula as p equals to amount divided by 1 plus I to the power n, which we can again rewrite as principal or present value is equals to amount multiplied by 1 plus I to the power minus n. So again, this becomes the formula for present value if interest is compounded m times in a year. So let's try to understand the concept of present value by a practical question. Now, the question here states that Mr. X has rupees 50,000 which he has divided between his two daughters, Divya and Neha, and the same is being invested somewhere which amounts to a certain sum of money at the end of 5 years. Neha also invests the amount somewhere which gives an equal amount after 7 years, which means that both Divya and Neha would be getting equal amounts after 5 years and 7 years. We need to find out what the amount is. So let's solve it. So we all know that both will be getting equal amounts. So let the amount after 7 years or after 5 years and 7 years for Divya and Neha be x. So therefore, what will be the present value of Divya's investment or Divya's share? The present value would be amount 1 plus I to the power minus n. The amount we have let it to be x, so it is equals to x 1 plus I, which is 6% compounded annually, so it is 0.06 to the power minus n, which is 5 years, so it is minus 5, which is x 1.06 to the power minus 5. Now the value of 1.06 to the power minus 5, we will search it from the back side of the book in the tables, and we get a value of 0.7462. multiplied by x, it becomes 0.7462x. Present value of Neha's share will be equal to amount 1 plus I to the power minus n. We all know that amount we have let it to be x because both Neha and Divya will be getting equal amounts. So 1 plus I is 0.06 and time period for Neha's investment is 7 years. So this becomes x multiplied by 1.06 to the power minus 7. Again we will find the value of 1.06 to the power minus 7 from the back side of the book, and we get 0.6670 multiplied by x, it becomes 0.6670x. Now according to the question, we know that present value of both the investments are equal to 50,000 because Mr. X has left only 50,000 today. So according to question, 0.7462x plus 0.6670x is equals to 50,000. Now we solve for the value of x and we get the value of x equals to 35,405.75, which is 35,405.75. So both the sisters, that is Neha and Divya, will be getting 35,405.75 after 7 years and 5 years respectively. Now the next topic that we will be considering is equation of value. This topic is also important from the exam perspective. So when we talk about equation of value, there would be different transactions taking place at different time periods. For instance, some transactions would be taking today, some transactions might be taking after 2 years, some transactions after 3 years, and some transactions after 5 years. So the equation of value would look something like this. Let's assume the above the axis we will be writing debts and below the axis we are writing payments. So at the end of year 2 there is a debt of 20,000, year 0 also there is a debt of 20,000, at the end of year 4 there is a debt of 40,000, and then at the end of year 6 and at the end of year 8 we are making two equal payments which are x. So here what's happening is there are 4 different dates on which transactions are taking place. Whenever we get such question, we need to decide a focal date. So focal date means the date on which we are considering all the transactions. We can take any date to be the focal date. We can also take focal date to be 10 years. We can also take focal date to be 12 years and so on. But it is always advisable to take a date as focal date on which transactions are taking place, which means either a debt is being taken on that particular date or a payment is being made on that particular date. So let's assume 6 years to be our focal date in this given example. So we are assuming 6 year to be the focal date, and also assume that the rate of interest is 8% per annum compounded annually. So in this case, if you consider 6 year to be the focal date, the formula for equation of value is value of debt on the focal date should be equal to the value of payments. So if I find out value of all these debts on 6th year, I need to add interest for 6 years in this 20,000. I need to add interest for 4 years in this 20,000, and I'll need to add interest for 2 years in this 40,000. So how will this take place? So the value of total debt is equals to 20,000 1 plus I, that is 0.08 to the power n. For this, n is 6 years, plus for second 20,000 1 plus 0.08 to the power. For this, the time period left till focal date is 4 years to the power 4, plus for this 40,000 1 plus 0.08 to the power 2, because the time gap between 4th year and 6th year is 2 years, will be equal to x plus, now for x we are not doing any discounting because the value of x in the 6th year will be equal to x only, plus x 1 plus 0.08 to the power minus 2, because the value of x would be at 8th year, so we need to discount it back for 2 years. So if we discount it back for 2 years, we are finding the present value. So now we'll look at the back side of the table to find the value of 1.08 to the power 6, which comes to 1.5868. Similarly, we find 1.08 to the power 4 and we get 1.3604. And similarly we find the value of 1.08 to the power 2 and we get this. Now we also find the value of 1.08 to the power minus 2, which we get 0.8573, which is multiplied by axiom. And after solving for x, we get the value of x equals to 56,856.73, which means that at the end of 6th year we will be paying 56,856 rupees, and also at the end of 8th year we will be paying 56,856 to pay off all our debts. Now let's do one more question to clarify this concept. A debt of rupees 5,000 is due 5 years from now and 5,000 due in 10 years from now, and it is to be repaid by a payment of rupees 2,000 in 2 years, payment of 4,000 in 4 years, and a final payment at the end of 6 years. So let's draw a timeline. So this is the timeline of the given question. Debt of rupees 5,000 due in 5 years, 5,000 due in 5 years, debt of rupees 5,000 due in 10 years, so debt of rupees again next 5,000 due in 10 years, which is getting repaid by payment of 2,000 in 2 years, 2,000 in second year, payment of 4,000 in 4th year, payment of 4,000 in 4th year, and the final payment at the end of 6th year. So at the end of 6th year I have let the final payment to be x. Now in this, firstly we need to decide the focal date. So let's assume the focal date to be the 5th year. So the focal date is 5 years. Now we all know that as per the equation of value of debt on a focal date will be equal to value of payment on that particular focal date. So the value of debts becomes 5,000 in 5th year will be 5,000 because it is due in 5th year only, plus second debt is due at the end of 10th year, so we will discount it for 5 years. So this becomes 5,000 1 plus I, which is 0.07 to the power minus n, which is minus 5, which is equals to value of all payments. First payment is made at the end of second year, so we will add interest for 3 years. So this becomes 2,001 plus 0.07 to the power 3, plus second payment is due at the end of 4th year, so we need to add interest for 1 year in this. 4,001 plus 0.07 to the power 1, and the final payment is due at the end of 6th year, so we will again discount interest for 1 year in the final payment, which becomes plus x 1 plus 0.5 0.07 to the power minus 1. Now we find these values from the back side of the book in the tables and right here. So the values which we get are 5000 is equals to 5000, 1.07 to the power minus 5 is 0.7129, 1.07 to the power 3 is equals to 1.2250, 1.07 to the power 1 is equals to 1.07, and 1.07 to the power minus 1 is equals to 0.9345. Now we solve this and find the value for x. So after solving this, we get the value x equals to 1963.08, which means that the final payment which is to be made after 6 years is rupees 1963.08.